Good afternoon. In the last lecture, we've seen that how to find the minimal polynomial for the real matrix A. Okay, and how to find the characteristic vector and characteristic values of the matrix A. Okay, now today we will see the last theorem of first chapter. Okay, any doubt in these examples?
No, sir.
Okay, now the last theorem of our first chapter now. Theorem. Okay, let V be the finite dimensional vector space. Let capital V over F be the finite dimensional vector space. Wait a minute. The finite dimensional vector space, and let capital T be a linear operator on V. Okay, vector space V. Wait. Then T is diagonalizable. T is diagonalizable if and only if and only if the minimal polynomial of T, that is capital T, okay, has of the form P of x is equal to x minus c1 into x minus c2 up to so on x minus ck. Okay, where all c1, c2 up to so on ck are the distinct characteristic values. C1, C2 up to so on ck, okay, are distinct characteristic or distinct element of f of capital F. Okay, now what is the theorem? Let V be the finite dimensional vector space and T be a linear operator on V, then T is diagonalizable if and only if the minimal polynomial for the T has of the form x minus c1, x minus c2 with algebraic multiplicity is 1 of each and every factor. Okay, so this is P of x is the minimal polynomial. Okay, now look at the proof now. Let capital T be a linear operator on n-dimensional vector space V over F. Okay, n-dimensional vector space V over F, and assume that T is diagonalizable. And we have to show that the minimal polynomial for T is P of x is of the form. Okay, x minus c1, x minus c2 up to so on x minus ck. Okay, that is the necessary part we have to do. So assume that if this T is diagonalizable, okay, and we have to prove that P of x is the minimal polynomial. Okay, if T is diagonalizable, then by the definition of diagonalizable, what we have, there exists an ordered basis, okay, ordered basis beta for capital V, such that the matrix of T with respect to beta is Am I audible? Hello.
Yes,
Yes,
sir.
sir.
So there is a network issue there. Hmm. Here the T is the linear operator on n-dimensional vector space. Assume that T is diagonalizable, then there exists a ordered basis beta for V such that the matrix A of T with respect to beta is diagonal matrix. Okay. This is the definition of T is diagonalizable. Okay. And the form of that matrix is block form. Okay. And it will have it will have the following block matrix. The following block matrix. Which one? Suppose this one is A, the matrix of T with respect to beta. So this is C1, I1. This is second C2, I2, and up to so on C, K, I, K. All the other entries are 0. Is it correct? And this is the matrix of order n cross n. Okay. If T is the diagonalizable matrix, then there exists a beta, basis beta for V, such that the matrix of T with respect to beta is diagonal matrix. Okay, here C1 repeated D1 times. If C1 repeated D1 times, then the order of I1 is G1 cross D1. If C2 repeated D2 times, then order of I2, that is identity matrix with order D2 cross D2, and up to so on CK. Okay, where C1, C2 up to so on Ck are what distinct characteristic values of T, where C1, C2 up to so on is Ck are distinct characteristic values of T. Okay, and each may be repeated times D1 times. Each may be repeated Di times. May be repeated Di times. Okay, C1 repeated D1 times, C2 repeated D2 times, up to so on Ck repeated Dk times. And Ij is what? Ij is Dj cross Dj. Okay, order of Ij is Dj cross Dj identity matrix. Any doubt up to here? Okay, now again, we know that what is the characteristic polynomial?
No, sir.
The characteristic polynomial is nothing but determinant of xi minus 2. Okay, we know that the characteristic polynomial, the characteristic polynomial for capital T is given by, okay, is given by f of x. Suppose this is f of x is the characteristic polynomial, which is equal to determinant of xi minus a. Okay, and is of the form f of x. Now here C1, C2, Ck are the distinct characteristic values, then determinant of xi is of the form, that is f of x is of the form x minus C1 bracket raised to D1, x minus C2 bracket raised to D2, up to so on x minus Ck bracket raised to Dk. Okay, we is an equation number 1. Okay, any doubt up to here? Now we have to prove
No,
the
sir.
claim. Okay, claim म्हणजे काय जे तुम्हाला प्रूव्ह करायचं आहे. Okay, p of x, we know that all the roots of characteristic polynomial is always also the roots of minimal polynomial, that is x minus c1, x minus c2 up to so on. हा प्रत्येक एक एक फॅक्टर ह्याच्यात येईलच. Okay, with algebraic multiplicity 1. Okay, is the minimal polynomial for t. Okay, so we have to show that p of x is the minimal polynomial for capital T. So give here equation number 2. Okay, so from 2 we can see that p of x is the minimal polynomial. How? Because the degree of p of x is the least degree. Okay, त्या p of x वरून काय सांगू शकतो आपण? p of x हा सगळ्यात कमी डिग्री असलेला पॉलिनॉमियल आहे जो t ला एनिलेट करू शकतो. Okay, which can annihilate the t. Okay, why? Because every root of f of x is the root of p of x. ओके म्हणजे x minus c1 हा फॅक्टर ऑलवेज तुमच्या p of x मध्ये असायला हवा. x minus c2 ऑलवेज हा फॅक्टर x minus c2 मध्ये असायला हवा. ओके म्हणजे या p of x मध्ये ह्याच्यापेक्षा कमी डिग्री पॉलिनॉमियल असलेला कमी डिग्री असलेला पॉलिनॉमियल तुमचा येणारच नाही जो t ला इंडिकेट करेल. Why? Because each and every root of f of x, that is characteristic polynomial of f of x, is again the root of minimal polynomial. ओके म्हणजे समजा मी आता समजा ह्याची डिग्री आहे k. ओके k मायनस वनचा डिग्री असलेला पॉलिनॉमियल जो टी ला एनिलेट करू शकत नाही. वाय? बिकॉज समजा हा मी फॅक्टर हा स्किप केला. सो व्हॉट इज p of x? x minus c2 x minus up to so on c3. Okay, whether this p of x annihilates t, whether the every root of f of x is a root of p of x. No.
No,
Okay,
sir.
तुमचं x minus c1 नाही आहे c2 त्या थेरम नुसार. Okay, so here p of x is the what? Least degree polynomial which can annihilate t. Okay, which can annihilate t. Now look at here. So from the equation we can see that p of x is minimal polynomial for t. Okay, and we have to prove that for this one p of t is equal to 0 operator. That means t annihilates p of x annihilates t. Okay, any doubt? हा असाही असू शकेल up to so on. पण हा लिस्ट पॉलिनॉमियल आहे लिस्ट डिग्रीचा पॉलिनॉमियल नो. ओके दॅट्स वाय तुमचा फायला प्रत्येक डिग्री प्रत्येक इच अँड एव्हरी फॅक्टर इज लिनियर फॅक्टर. Okay, and if we show that p of x is equal to 0 operator, then this p of x is what? Linear. Sorry, this p of x is minimal polynomial for t. Okay, now let alpha be any characteristic vector of t. Any characteristic vector for capital T. That is, suppose alpha corresponds to characteristic value Cj. Okay, suppose alpha with any characteristic vector for t, and suppose this alpha corresponds to a characteristic value Cj. Okay, then by the definition of characteristic vector, this t of alpha is equal to Cj into alpha. Okay, so that implies t of alpha minus Cj into I of alpha is equal to 0. That implies t minus Cj into I of alpha is equal to 0. Okay, any doubt up to here? If alpha is the characteristic vector for t. Okay, and suppose this alpha is characteristic vector corresponds to the characteristic value the Cj, then t minus Cj of I. Cji of alpha is equal to 0. Okay, now put x is equal to t in equation number 2, this one, p of t. Put x is equal to capital T in equation number 2 and apply on alpha. So what we get then? P of t of alpha is equal to p minus x minus c1. So this is c1I of alpha. Okay, actually have a but t minus c2I into t minus c3I up to so on t minus cky of alpha. Okay, So that is now P of T of alpha is equal to T minus C1I of alpha into T minus C2I of alpha, and up to so on. This is T minus CKI of alpha. Any doubt here? Okay. So
No,
this
sir.
implies this B of T of alpha is equal to 0. This is equation number 3. How it is 0? Because T of Cj of alpha is equal to what? 0. Okay.
0.
Reason पहा काय P of T of alpha is equal to 0 for all characteristic vector alpha of T. Okay. आता तुमचं काय alpha be any characteristic vector for T. Okay, and suppose this alpha corresponds to the characteristic value Cj, and P of T is P of T of alpha is equal to 0 for all characteristic vector alpha in T. Okay, here is the condition 0 3. Okay, now look at here. Here the vector space V is spanned by vector space V is spanned by all characteristic vector of T. Why? Because T is diagonalizable. Okay, काय assume केलं आपण? What we assume? T is diagonalizable. What is the meaning of diagonalizable? Each and every vector is what? Basis चा प्रत्येक vector काय असतो माझा? Suppose B is the beta is the basis containing n vectors. So each and every vector is what? Characteristic vector. Why? Because T is diagonalizable. So there exists a basis beta for V such that each and every vector is characteristic vector. He पण definition पाहिलेली आहे आपण. Okay. Okay, is it correct? Okay, मागचं
Yes, sir.
पाहता. त्याशिवाय नाही करणार. Another meaning of T is diagonalizable meaning is what? Each and every vector of that basis is characteristic vector. Okay, and this vector space V is spanned by is what? All characteristics vectors of T. म्हणजे तुमचा जो बीटा मधले जे काही वेक्टर्स असतील अल्फा 1 अप टू सो ऑन अल्फा n. Okay, हा अल्फा 1 अल्फा 2 अल्फा 3 अप टू सो ऑन अल्फा n हे काय असतील? ऑल द वेक्टर्स आर कॅरेक्टरिस्टिक वेक्टर. दॅट इज T ऑफ अल्फा 1 हा कोणाच्या तरी करस्पॉन्डिंग टू C1 ला काय असतो? कॅरेक्टरिस्टिक वेक्टर असतो. Okay, why? Because T is diagonalizable. Okay, any doubt up to here? So here vector space V is spanned by all the characteristic vectors of T. So therefore equation 3, okay, equation 3 is true for equation 2 is true for all vectors in V also. That is P of T of beta. Okay, suppose B is equal to 0 for all B belongs to capital V. Okay. Suppose this is the vector space and this is B is the any vector belongs to V. So this V we can write in the form of A1, alpha 1, A2, alpha 2 up to so on AN, alpha n. Is it correct?
Yes,
Okay,
sir.
so here each alpha 1, alpha 2 up to so on alpha n is the characteristic vector. Okay, but here, look at here. Alpha be the characteristic vector, any characteristic vector for T corresponding to Cj. Okay, so here alpha 1, alpha 2, alpha 3 up to so on alpha n is the characteristic vector corresponding to some characteristic value. Okay, if you apply P of T on any vector of beta, then it becomes 0. ओके ओके ह्याच्यावर जर मी कोणताही टी ऑफ बीटा अप्लाय केला तर काय होईल टी ऑफ अल्फा वन टी ऑफ अल्फा ओके तर तो काय होईल
Yes, sir.
बेसिसला झिरो करतोय तर मग पूर्ण वेक्टर स्पेसला झिरोच करेल ना तो टी ऑफ टी कळते काय सांगतोय एखादा ऑपरेटर तुमच्या बेसिसच्या प्रत्येक वेक्टरला झिरो करतोय ओके तुमचा अल्फा काय अल्फा इज दी कॅरेक्टरिस्टिक वेक्टर म्हणजे कुठे आला तो बेसिस मध्ये ओके each and every characteristic vector is what basis so here get it p of t on beta is equal to 0 so that implies p of t is equal to 0 vector that implies p annihilates capital T. Okay, so from 1 and 2. From 1 and 2. What is 1 equation? This one. And 2. This P of x is what? Minimal polynomial for T. Okay, you can see that from 1 and 2, we can see that no polynomial having degree less than P of x less than that of P of x can annihilate T. Okay, any doubt? Hence, this P of x is what?
No, sir.
Minimal polynomial for T. Okay? Okay? पहा पुन्हा हा P of T काय करतोय P of T for each and every characteristic vector is equal to 0. ओके बट कॅरेक्टरिस्टिक वेक्टर म्हणजे काय तुमच्या व्हीचे काय सगळे बेसिस वेक्टर वाय बिकॉज टी इज डायगोनलायझेबल if t is diagonalizable then each and every vector in basis is the characteristic vector हा प्रत्येक कॅरेक्टरिस्टिक वेक्टरला काय करतो झिरो करतो तर बेसिसला झिरो करत असेल तर तुमच्या वेक्टर स्पेसला तो झिरो करत असेल हो की नाही इज इट करेक्ट दॅट मीन्स p of t is equal to 0 operator. That means P annihilates T. That means P of x is the minimal polynomial for T. Any doubt up to here?
No,
Now
sir.
conversely, if suppose P of x is equal to x minus c1, x minus c2, up to so on x minus ck, then we have to show that T is diagonalizable. ओके हे ह्याच्याकडे नीट लक्ष द्या कारण जरा हा कॉन्व्हर्स पार्ट मोठा आहे खूप आणि किचकट पण आहे ओके अवघड नाहीये पण किचकट आहे पार्ट भरपूर गोष्टी अजून कराव्या लागतील तुम्हाला ओके कॉन्व्हर्सली assume that now if I assume that p of x is equal to x minus c1 x minus c2 up to so on x minus ck okay each a minimal polynomial for t okay where c1 c2 up to so on ck are what distinct characteristic values distinct characteristic values of capital T, and we have to prove that T is diagonalizable. Okay, T is diagonalizable. Now let W be the subspace spanned by all characteristic vectors of T. Let W be the subspace spanned by all of the characteristic vector, okay, of capital T. W का तुमचा subspace spanned by all characteristic vector of T, and we have to prove that if T is diagonalizable म्हणजेच काय तुमचा W is equal to मला V दाखवायचं. Okay, what is claim? W is equal to V. जर तुमचा V is spanned by all the characteristic vectors of T जर झाला तर हा T कसा होईल diagonalizable. Is it clear?
Yes, sir.
Okay. Now, if possible, assume contradiction method. If possible, suppose this W is not equal to, assume that कुठेतरी जाऊन पुढे कॉन्ट्राडिक्ट मिळेल आपल्याला स्टेटमेंट, मग तो काय W is equal to V होईल. Okay, if possible, assume that this W is not equal to V. Okay, and let the dimension of W is equal to K, which is less than n पेक्षा कमी असेल तो. Okay, and let the basis for B where W is beta, that is alpha 1, alpha 2, up to so on, alpha K, be any ordered basis for W. Okay, and what we have, T of alpha I is equal to, T of alpha is what? Is equal to Ci into alpha I. Okay, dimension of W is equal to K and beta is equal to alpha 1, alpha 2, so on, alpha K be any ordered basis for beta, and as we can T of alpha is equal to Ci into alpha I, where I will from 1 to up to so on K. Now, obviously, from this statement, alpha I belongs to W. This Ci into alpha again belongs to W because dimension of W is K. Okay, this W is spanned by these K vectors. If alpha 1 belongs to W, then Ci into alpha again belongs to W. So obviously here the T is W is invariant under T. Okay, is it correct? Invariant under
Yes, sir.
capital T. कसा आला हा alpha 1 basis हा त्या सबस्पेसचा काय असतो ऑलवेज सबस्टेट असतो. Here the beta is the subspace. Beta is contained in W. That means this alpha 1 belongs to W. T of alpha I Ci into alpha I as a defined. So this product Ci being any scalar. Okay, this product also belongs to again W because W is the subspace and subspace म्हणजे काय असेल closed under multiplication, scalar multiplication. So here the W is invariant under T, and what we have, W is not equal to V. That is, W is, as we W is not equal to dimension of suppose W is not equal to V here. That is, W is proper invariant subspace. Proper invariant subspace under T. Subspace of capital V. Then by using lemma, previous lemma, एक्झाम्पलच्या आधी घेतलेल्यानंतर, ओके, तो लेमा होता था. By using previous lemma, there exists a vector alpha belongs to V such that, okay, तेरा पहला होता V काढलेला, this one is W. Okay, alpha belongs to V, but alpha not belongs to W, but T minus Cj of I of alpha belongs.
Cj of alpha is,
Okay,
belongs to W.
okay, so there exists a vector alpha belongs to V such that this alpha not belongs to W, but T minus Cj into I of alpha belongs to W. Okay, give the equation start. Okay, any doubt up here? ओके, हा तुमचा काय आला तर बीटा
No, sir.
मधला वेक्टर. लेट भरपूर गोष्टी अज्युम कराव्या लागतील बरं का, घोळ होण्याची शक्यता आहे. लेट धिस इज बी टी मायनस सी जे, या वेक्टरला नाव दिले सी बी. ओके, ऑफ अल्फा. ओके, देन this beta belongs to what? W. B belongs to W. Okay. Now, thus, हा काय आला तुमचा बीटा. बीटा इज इक्वल टू टी मायनस सी जे इंटू आय ऑफ अल्फा. Thus, B belongs to W implies this beta or B we can write in the form of linear combination of vectors of what? Basis. Okay, alpha 1, alpha 2. Okay, this is the basis for W. Na? So this B we can write in the form of linear combination of alpha 1, alpha 2, up to so on alpha k. Is it correct? A1
Yes,
alpha
sir.
1, A2 alpha 2, up to so on. This is A k alpha k, where each AI belongs to F. Okay, are scalars. Now let याला नाव दिले आपण B1, याला नाव दिले B2. Okay, let this BI is equal to AI into alpha I, where I running from 1 2 up 3 up to so on k. याला काय म्हटलंय B1, याला B2 up to so on. This is BK. Okay, any doubt up to here?
No,
एक एक
sir.
एक एक पार्ट लक्षात ठेवा, नंतर मग तुम्हाला थीम लक्षात ठेवायला सोपी जाईल. म्हणजे प्रत्येक स्टेप समजते का नाही हे पाहता. Okay, now here beta is equal to a1 alpha 1 plus a2 alpha 2 up to so on ak alpha k, and let this bi is equal to ai into alpha f, or I running from 1 to k. Okay, since we know that if alpha I is what? Characteristic vector corresponding to characteristic value ci, characteristic value ci, then if alpha is suppose characteristic value vector belongs to ci, then ai into alpha is what? Scalar multiple of characteristic vector is again characteristic vector corresponding to ci. Okay, is it correct? If alpha I is the characteristic vector corresponding to
Yes, sir.
characteristic value ci, then ai into alpha I is also what? A characteristic value. Okay, is characteristic value corresponds to same eigenvalue or same characteristic value ci. Okay, so therefore this bi, okay, ai into alpha, scalar multiple of alpha, is characteristic vector corresponding to same characteristic value what? Ci. Is it correct? Then this T of beta I or Bi is equal to what? Ci into Bi for all I running from 1 2 up to so on k. Is it correct? This is equation number
Yes,
one.
sir.
Okay. Now since beta is equal to what? B1 plus B2 plus up to so on Bk. Okay, B1 plus B2 plus up to so on Bk. Okay, now again assume let h of x belongs to capital F of x be any polynomial. भरपूर गोष्टी assume करायच्या बरं का. Any polynomial. Then what is h of t of beta or b is equal to, this is h of t, apply on this one, b1 plus b2 plus up to so on what? Bk. Okay, which is equal to h of t of b1, h of t of b2 plus up to so on h of t of bk. Okay, if t is linear operator, h of t is linear again operator. Okay, and b1, b2, b3 up to so on, bk are what? Characteristic vector corresponding to alpha. Okay, c1, c2 up to so on, ck. Look at here, b1, b2, b3 are the characteristic value corresponding to c1, c2, cp up to so on, ck. Okay, respectively. Then what is the value of this one? H of t of beta is equal to h of c1 स्केलर काय येईल तुमच्या इथे आता हा ऑपरेटर झाला. ओके, हा तुमचा काय ऑपरेटर, हा तुमचा स्केलर, दिस इज स्केलर ना सी आहे. एच ऑफ टी असेल तर ऑपरेटर काय येईल? एच ऑफ सी आहे ना. ओके, पाहिलं थिअरम तो एच ऑफ सी वन ऑफ बीटा वन प्लस एच ऑफ सी टू ऑफ बीटा टू. ओके, up to so on h of ck of bk. Is it correct? Why?
Yes.
Because f of t of alpha is equal to f of t into alpha, where a is the what characteristic value of t. Okay, हा theorem लिहिलेला. ओके, कोणता theorem पुन्हा लक्षात घ्या. स्टेटमेंट सांगतो त्या theorem. If t of alpha is equal to a into alpha or c here, c into alpha. Okay, if alpha is the characteristic vector corresponding to c, then for any polynomial f of x, we have what we have f of t of alpha is equal to f of c of alpha. हा तुमचा कॉन्स्टंट आहे. ओके, हा ऑपरेटर आहे, लक्षात ठेवा. ओके, एनी डाऊट? आता नीट लक्ष
No,
द्या.
sir.
This beta 1 belongs to W. This beta 2 belongs to W. This beta k belongs to W. T is anywhere. Okay. And h of C1, scalar, scalar. Scalar into W is W. Scalar into W is again W. हा तुमचा W मध्ये पूर्ण पार्ट. हा तुमचा W. This one is W. So whole h of T of beta belongs to what? W. Is it correct? Okay. So therefore, h of T of beta, this element belongs to W. What is the reason? Since Bi belongs to W and W is subspace, that is itself is first vector space, and h of what? Ci's are scalars. Any doubt? Then h of t belongs to what? W. Okay. Any doubt up to here? Leave it as an equation number 2. Okay.
No, sir.
From p of x, what is p of x? In numbers. In the converse part. In the converse part, what is p of x? X minus c1, x minus c2, up to so on, x minus ck. Okay, now look at it. Now, this p of x can be written as p of x is equal to, okay, x minus c1 into x minus c2 up to so on, x minus ck. So here x minus ck into g of x. Okay, or q of x. असं लिहू शकतो का? येस. कुठला तरी c1 मी c2 अप टू कुठला तरी हा cj मी ठेवलाय तसंच, and all the factors is in the form of q of x, product of all the factors. Okay, p of x कसा होता तुमचा? p of x is equal to x minus c1 up to so on x minus ck. Okay, so we can write p of x is in this form. Okay, x minus c1 तसाच ठेवला आणि बाकीचा जो प्रोडक्ट आहे तो काय घेतला मी p of x. Okay, any doubt? So this is the equation number 3. Now
No, sir.
define function. Okay, define one polynomial p of x is equal to q of x minus q of cj. Okay, q of x. Okay, also, but we have q of cj. Now zero येईल का q of cj? ओके, या q of x मध्ये cj हा फॅक्टर आहे का माझा? कळतंय का काय? What is q of p of x? P of x is equal to, we can write p of x is equal to x minus cj into all the factors, product of all the factors, the remaining factors is equal to q of x, and also this q of cj is not equal to 0. Is it correct? Okay, why? Because in the q of x, x cj
Yes,
हा
sir.
दोनचा फॅक्टरच नाही आहे. ओके, तो वेगळा दिले ना. Is it correct? So q of cj is not equal to 0 here. Okay, now define one polynomial k of x is equal to q of x. घ्या तो q of x इकडे minus q of cj. Okay, then what is k of cj? Put x is equal to cj. Wait, x is equal to cj is equal to q of cj minus q of cj is equal to what? 0. So that implies cj is root of k of x. Is it correct? Okay, k of x का
Yes,
येतो?
sir.
Yes, sir.
Root आहे. कोण? cj is the root of k of x. So that means we can write this k of x is equal to x minus cj into some polynomial g of x. Okay, is it correct? Consider polynomials those x minus cj. But what is k of x? This one, which is equal to q of x. Okay, हा g आहे बरं का? हा g of x into x minus cj into g of x is equal to this is q of x minus q of cj. Any doubt?
No, sir.
No, sir.
Okay, now पहा हा ही स्टेपच महत्वाची होती सगळ्यात. सो x minus cj into g of x. ओके, जर cj हा माझा k of x चा फॅक्टर असेल तर तो फॅक्टर मी बाजूला काढून बाकीचा जो टर्म असेल त्याला g of x नाव दिलं. ओके, सो x minus cj of g of x. आणि काय डिफाइन केलं फंक्शन? q of x minus q of cj. Okay, for some polynomial g of x belongs to capital F for x. Okay, so this implies, wait a minute, q of t. Okay, put x is equal to t here, minus q of cj is equal to g of t into t minus cj into I. Is it correct? Put x is equal to capital T. Okay, so this implies q of t minus q of cj is equal to g of t. Okay, wait, apply this of the term alpha first. G of, sorry, q of t, okay, of alpha minus q of, हा तुमचा स्केलर आहे बरं का, स्केलर cj into I of alpha is equal to g of t of into t minus cj of I alpha. Okay, so this implies, what is the value of this one? From star, look at here. What is the value of this one? T minus cj of I into alpha is of alpha is beta. Okay, so here we get this g of t of alpha minus q of cj into I of alpha is equal to g of t, this operator on beta. Okay, why? Since t minus cj into I of alpha is equal to beta. Any doubt over here? Beta belongs to what?
No, sir.
कुठे होता तुमचा W? T is linearly T is W is invariant under T. Okay, then W is invariant under any of the G of T. Then this G of T always also belongs to W. Is it correct? Okay, high element कुठे आला तुमचा आता W. That means this
Yes.
implies
Yes, sir.
G of T of alpha minus Q of Cj into R of alpha. This element belongs to W. Okay, give it as an equation number 4. Okay, that we have written now third there. Okay. Okay, now g of t of alpha minus, sorry, here q, sorry, q, this is
Q
q,
is
na? Q of t of alpha minus q of cj into I of alpha belongs to w. Okay, give it as an equation number 4. Now from equation 3 implies what it implies equation 3. What are equation 3? Okay, what is p of t? P of t is equal to t minus cj of I into q of t. Okay, p of t is equal to t minus cj of I into q of t. Okay, what is p of t? Zero operator. Why? Because we assumed that p of x is the minimal polynomial. Okay, so this implies this is equal to t minus cj of I into q of t. What is the reason? P of x is what? Minimal polynomial. We assumed. Okay, so apply on the alpha now. Zero operator on alpha is t minus cj of I of q of t on alpha. Okay, now 0 of alpha is what? 0. Now this is t minus cj into I. Now assume this q of t of alpha is gamma, since q of t of alpha is equal to gamma. Okay, so that implies t of gamma is equal to cj into I of gamma, which is equal to cj into gamma. Okay, any doubt up to here? Okay, भरपूर गोष्टी आपल्याला अजून करायच्या आहेत, त्यामुळे अवघड वाटत
No,
असेल.
sir.
Okay, so gamma is t of gamma is equal to cj into gamma. What is gamma? Q of t of alpha. Okay, now if that is if gamma is not equal to 0, then what we have gamma is जर gamma जर 0 नसेल तर काय होईल? Gamma is characteristic vector by the definition. Okay, characteristic vector of capital T corresponds to characteristic value Cj. Is it correct? Okay, जर हा तुमचा
Yes,
जर
sir.
characteristic value असेल, okay, gamma is equal to gamma कुठे असेल मग माझा? Invariant under T. So this gamma belongs to what? W. Okay, by definition. Okay, so then what is gamma? Q of t of alpha belongs to W. Okay. Okay, any doubt up to here?
No,
No,
sir.
sir.
कळालं कसा आला gamma belongs to W?
Yes,
This
sir.
T of gamma is equal to Cj into gamma. Okay, so here the gamma is the characteristic vector of T corresponding to Cj. Okay, now hence the Q of T belongs to W, and also wait, this Q of T of alpha belongs to W. Okay, give it as an equation number 5. Okay, now this Q of T of alpha belongs to W also. And also, suppose our H value was 0 of alpha is equal to 0. Then, obviously, the minus of Q of T, wait, minus Q of T of alpha. Okay, that's a negative part. High castle belongs to W if G of T is of alpha is equal to 0. Okay, so from 4 and 5, if Q of T of alpha belongs to W and W is the subspace, then this is additive subgroup. Additive subgroup म्हणजे हा त्याचा निगेटिव्ह पार्ट पण त्या W मध्ये असणार. ओके, तो 0 असू द्या किंवा नसू द्या, 0 असला तरी असेल, नसला तरी असेल. ओके, then G minus Q of T of alpha also belongs to W. So from 4 and 5 we have the addition of the 2. What is 4? This one. This one belongs to W. 5 fifth term also, this one also belongs to W. Then the addition also belongs to W. That means this minus Q of T of alpha plus Q of T of alpha minus Q of Cj, Cj into alpha. Alpha I yes, I of vector Q. Okay, of I belongs to W. Okay, now this term get cancelled, so that implies minus Q of Cj. Okay, into I of alpha belongs to W. Okay, any doubt up here? This implies this is minus Q of
No,
Cj,
sir.
and I of alpha is alpha, again belongs to W. Okay, now look at here. This is what? Q of Cj is one scalar, and alpha is the vector. Okay, then suppose this minus Q of Cj is equal to A. So that implies A into alpha belongs to what? W. Okay, this implies A is the any scalar belongs to F. Okay, हा तुमचा scalar आहे. That means alpha again belongs to W. Is it correct? Hence,
Yes, sir.
we get contradiction to our assumption. Which contradiction? Look at here. Okay, alpha not belongs to W. Is it correct? Okay, here we
Yes,
get
sir.
alpha not belongs to W, but here we get alpha belongs to W. Why we get this contradiction? Because of our wrong assumption. What is assumption? This one. Suppose if possible, W is not equal to K. By this wrong assumption, we get the contradiction. So this statement is what? Wrong. Hence, W must be equal to V. Okay. And K must be equal to N. Okay. So here we get the contradiction to our assumption. Okay. which is hence we get contradiction. To fact all C1, C2 up to so on Ck are what? Distinct. Okay, hence this W is not equal to V, it's not true. Therefore, this W must be equal to V. That implies W is spanned by all characteristic vector of T. Okay, so then by the definition of diagonalizable, by the definition of diagonalizable, the linear operator capital T is diagonalizable. Is it correct? Any doubt up to here? ओके स्टेप बाय स्टेप लक्षात ठेवा कुठली स्टेप नाही समजून तुम्ही लक्षात ठेवा ओके
हो सर.
थीम तुम्हाला ते प्रॅक्टिस करूनच करावं लागेल ओके